So after I will give you a good overview about the whole context of EPDs and why c-PCR is maybe used, I will get a bit more detailed, a little bit, put a bit flesh to the bone, very pragmatic. How could that look like? Because unlike Amut, I had a working group with a very narrow scope. We are just looking at air filters. So for obvious reasons, we are in our work a bit more advanced. So we can really see what is specific for an air filter. And where does it actually need specific rules? And where are the general rules of 15804 maybe a bit too broad? So having said that, if you look at air filters, what's special about an air filter when it comes to an EPD? The first and utmost one, an air filter is obviously a passive component. There's no cable to connect to it, there's no plug, it actually uses officially no energy. But during the use of an air filter, the vast majority of this your CO2 emission is by the energy, which is a contradiction in itself. And if you look at that example here on the right, you see that for a typical air filter with 1 year lifetime, only about 4% is the product at its disposal, which means far more than 90% is the energy consumption. So how to overcome that gap? On the one side, it's a passive component. So in the LCA, the energy consumption is zero. In reality, the energy consumption is a vast majority. And of course, selecting an energy efficient or less energy efficient air filter has a big impact on the sustainability, on the carbon footprint. That's what the whole thing is about. So first thing we have to overcome, that requires c-PCR. Secondly, what is an air filter made for? It's made for removing particles or gases. So it has a positive impact on the indoor air quality. If I don't consider that at all, then the best solution is no filter, which is obviously the rock choice. Second thing we need to consider. And then we have another one, which is more internal issue. Air filters are standardized products. Unlike many air handling units, we cannot know where the air filter actually goes to. And at the same time, air filters come due to the different types of air handling units you have. They come in very many sizes, which means if you have, for instance, a panel filter, technically the same product can come up in thousands of sizes. So that would mean if our declared units, we make DPD for one air filter of a specific size, one manufacturer would need to do thousands of EPDs for one product. That's obviously not very efficient. So we have to find another declared unit which still makes sense. And last but not least, we have lifetime. An air handling unit has a lifetime of decades. An air filter typically has 1 year. So that tells you there's a lot of things we need to consider which are not standard versus other products. And the same logic, of course, with different issues would apply to any of the components Amut has in this group. So that's really a challenging work. So our work actually came to a lot of conclusions because we have a narrow scope. So the group was, the decision to found that group was in May 2023 in the General Assembly of CEN TC195. 2 months later, we started with the first physical meeting. You see here a few of the physical meetings that have taken place or will come. In between, we had, of course, a few Teams meetings. And as you see from the timeline, we're actually targeting to have a pre-EN ready by end of this year. So relatively short time frame when we talk about a segment. So what can you expect to be in there? A few answers to the questions I raised. First of all, energy consumption. How do we overcome that? So what we did in the working group, we built a model very much based on the Eurovent guideline 424, which is already existing for comfort filters, so PM10, PM2.5, and PM1 filters. And we widened the scope so that it also fits for coarse filters, for molecular, for HEPA, and may find a way to give an energy consumption in kilowatt hour to each filter that will be part of the general information. Because it's not supposed to be in the LCA, but it needs to be communicated. So you still have the possibility to select a filter based on its energy efficiency, but we're not messing up with the EPD rules. Number one, biggest impact. Second was actually relatively easy, the impact on indoor air quality. In the original 15804, there is an impact on disease incident rates, one of the other things you can report besides CO2 emissions. And there is actually also a formula in the model given how reduction of PM2.5 or increase of PM2.5, depending on your product, affects the disease incidence rate in the building. So we can, of course, an air filter will remove PM2.5. And as any air filter has a PM2.5 efficiency, you can easily calculate the impact and give it as a factor in the EPD. Which means, of course, a better air filter may have a higher energy consumption, but will have a higher PM2.5 efficiency. So you can make a qualified decision. And then, of course, the issue is the sizes. And there we stole was tried an idea someone else had. As I said earlier, a filter can come basically in any size. But the same applies to a window. Windows come in every size of the building. And the guys working on the c-PCRs for Windows in the EN 7213 from 2020 already found a solution how to scale an EPD. So they basically, a window is declared by 1 square meter, depending on a few standard sizes. And a lot of our work was to see which air filter sizes are typical, how does the impact in terms of material disposal actually change between the different sizes, and what size ranges are reasonable. And we ended with 2 sizes. So basically, with what we call a full-size filter and a half-size filter, you can cover the whole range. Which means any filter being larger than 29 square decimeters, so 3/4 filter, full filter, or bigger, will be calculated based on the full filter on the square decimeter face area. Everything below will be calculated on half size, which brings us down from thousands of EPDs to 2 EPDs per product range, which is much more reasonable. And there we come already to the end. You see, within less than 2 years, we fixed all the major issues we could face in terms of air filtration. So we expect to be ready earliest, with a final standard earliest in 2026. Of course, it depends on the comments we get. But our pre-EN, we targeted to be ready by end of this year. So we have 2026 for review and next iterations. So this EPDs will allow a fair comparison all over Europe, an air filter with all its components, the efficiency, energy consumption, but of course also material and waste also. So, all the energy consumption as said is the general information, not to be mixed up with the B6 and the LCA, because otherwise you would have a double calculation. Because if I put the energy consumption to the air handling unit, to the fan, and to the filter, you would calculate it 3 times. So, impact on indoor air quality will also be considered. And as I said, we come down from a multiple of EPDs to only 2 EPDs for the full range, which also allows a better use in the c-PCRs or an LCA for a building. Because imagine if you have a big handling unit with some full-size filters, some 3/4, some half, some quarters. What do you want to use? Tons of different EPDs. Now you just know these many square decimeters you have, and you can put it in the LCA application. Much more pragmatic. Thanks.